Welcome to Math 158, Functions, Graphs, and Matrices. This section is section 0.8 from the text that we're using, Logarithms. It's a section looking at logarithms. There's something we don't use as much as we used to. The technologies that we have made things a little bit easier. But we're going to do a quick review of logarithms. Okay, so what the purpose of a logarithm for is to solve for an unknown exponent. I have the example here, y equals 3 to the x, and I kind of split my equation, so let's write it off to the side over here. If I have y equals 3 to the x, and I let x equal 4, y equals 3 to the 4th, and I can use my calculator, 3 to the 4th, hopefully you know this, is 81. So y equals 81. That's fairly simple. Let's look at another example. If we're given a value for y, this is not quite as simple. So if we're told that y equals 3 to the x, given a value of x, solve for y is fairly simple. Given a value of y, solve that for x is a little bit more difficult. Actually, it's quite a bit more difficult. Notice that the unknown value is in the exponent. So what we want to do is take a little look at logarithms, okay, and what they can be used for. So for example, the base b of a logarithm x, log base b of x. That's the power to which we need to raise b in order to get x. In other words, if I take the statement y equals b to the x, that's the same as saying that x is equal to log base b of y. And I want to be able to convert back and forth. The equation we had, y equals 3 to the x. The base of the exponent is 3, therefore the base of the logarithm is 3. Y equals 3 to the x. Y is what this solution is, so log base 3 of y equals x. And this kind of follows because the purpose of the logarithm is to solve for that exponent. Okay, if I have the equation y equals 7 to the x, log base 7 of y is equal to x. Okay, so for example, suppose we have y equals 10 to the x and y equals 1000. 10 to the x equals 1000. In other words, log base 10 of 1000 equals x. And that value of x would be 3 because 10 to the third is equal to 1000. Okay? Logarithms can be a little bit difficult to work with. Now, there's some algebraic properties of logarithms that I want to review very quickly, and I've done this, I want to say, in a video earlier in this course. But log base b of xy equals log base b of x plus log base b of y. This comes from the fact that what the exponent is, what the logarithm is it is an exponent. Okay? If I'm multiplying two numbers, x and y, with the same base b, I add their exponents. Okay, so the log base b of xy is log base b of x plus log base b of y. Log base b of x divided by y. If I divide x and y, two numbers with the same base, I subtract their exponents. And this is where these laws come from. Okay, now those two laws we use, and I'm not going to go super in-depth in them in this video because that's not the purpose of where we're going to go in this course with the logarithms. What I want to do is I want to spend our time looking at, yes, the rules, but also how they're applied today. This rule, the third rule, log base b of x to the r equals r log base b of x, is the rule that we're probably going to wind up using the most in this lesson. Okay, rule 3 and rule 4 will get used the most. Now, where this rule comes from, suppose I have log base b of x squared. That's log base b of x times x. And if I employ this rule up here, where the x and the y both equal x, using the fact that log base b of the first plus log base b of the second, so log base b of x plus log base b of x would equal 2 times the log base b of x. So you notice that this exponent here, the 2, winds up out front. Okay, so that's a rule. Let me just show that again. Suppose I have log base b of x cubed. That's the same as the log base b of x times x times x, since x to the third is x times x times x. Now, employing rule number 1, that tells me that this is log base b of x plus the log base b of x plus the log base b of x. Notice I have the same thing 3 times, so that's 3 times the log base b of x. And this exponent here, 3, becomes this coefficient. Okay. Logs do take some practice to work with, and I'm not going super in-depth in this video into the rules of logarithms. There should be a video soon going more in-depth into the rules of logarithms, and you can look for that. This rule here, log base b of b is equal to 1, that comes from the fact that if I change this back, this means that b to the first power is equal to b. Okay, the log base 3 of x is equal to 1 would tell me that 3 to the first equals x. I changed this from the logarithmic form back to the exponential form, so clearly this x would be 3. So the log base 3 of 3 is equal to 1. Okay, so there's a basic rule there. Recall, for here, let me get this guy out of the way, anything to the 0 power is 1. So log base b of 1 is equal to 0. So anytime that's a 1, we're going to have 0 here. So those are the rules that get used the most. Okay. These last two rules, log base b of 1 over x equals negative natural log of b. If you recall, 1 over x is equal to x to the negative 1. Again, that's been covered in a previous video. So the log base b of 1 over x is the same as the log base b of x to the negative first. But remember, here in rule 3, that exponent r becomes the coefficient. So that's the same as negative 1 times the log base b of x. Okay. Rule number 6 is what's called a change of base rule. And it's a rule that we could use. So for example, if I've got the log base 3 of x, and I don't want to use the base 3, what I could choose to do, say, I'd rather work in base 10, or because the calculator is going to work best in base 10. In fact, what we're going to do in this class is predominantly going to be base 10. Some of you may understand the natural log, which is a base e, and you can work in that base if you would like to. But if I want to work in base 10, I can just say log base 10 of x divided by the log base 10 of 3. And we have what's called the change of base. This is called the change of base. Because notice here the base of my logarithm is b, and here the base of my logarithms are a. And really what I'm going to do in this video is not need to use the change of base rule, because I'm going to show you how to solve functions, exponential functions, where I need to solve for the x without creating a problem where I've got a base that I don't want. Okay, so now if I look here, just some practice with logarithms. Okay, here we want to evaluate the logarithm, log base 5 of 125. I'm going to argue that this is easiest if I consider that I want to let this equal x. Okay, so now if I change this from logarithmic form, log base 5 of 125 equals x, and I change this back into exponential form, that means that 5 to the x power equals 125. And I just know that x is 3. So some of these are knowable, right? So 5 to the third is equal to 125. So I can just know this. Notice that there is no base here. when there is no base written, it's understood that the base is 10, and that's called the common log because we most commonly use 10 as the base for our numbers in modern mathematics. So log of 100 is the same as log base 10 of 100. It's base 10. In fact, you'll notice here in the calculator next to the 7 button it says log, L-O-G. That is the log base 10, or the common logarithm. So if I want to solve log base 10 of 100 equals x, and remember that base that's not written there is a 10, 10 to the x equals 100, right? 10 to the x equals 100. And we just know, I hope, that x would be 2 because 10 squared is 100. So number 3, again, if I let this equal x, 2 to the x equals 1/16. And if I remember that this is the same as 16, 2 to the 4th is 16. So 2 to the negative 4th would be 1/16. So I can just know that x is negative 1/4. Okay. So with my rules of logarithms, just to do some practicing here, and quite honestly, number 4 and number 5, I'm going to skip through this fairly quickly just because for this course, this is not a lot of what we're going to need here for this course. But log base 2 of 3 minus log base 2 of 4 is log base 2 of 3/4. Okay, because I'm subtracting the exponents, which means I'm dividing the 3 and the 4. Number 5, I've got the log of 5 minus 3 log x. That means I'm going to divide by x to the 3rd. Plus, that means I'm going to multiply x plus 1 to the 1/2 power. Okay, that goes fairly quickly, but I want to move on to the following problems, which are much more of what we're going to be using in this course. Number 6. I'm going to take a few minutes here to build number 6. So I can look at this, and I used this example before. I can look at this and just know that x equals 4 since 3 to the 4th equals 81. So there's an option. That's great if I can just look at that and know what the solution is. Okay, but I'm not sure that it's fair to expect that I'm always going to be able to look at these things and just know that the value of x is equal to 4. Okay, so here's another option. Log base 3 of 81 is equal to x, right? Log base 3 of the 81 is equal to the x. Well, that's great. I got this from exponential into logarithmic form, but unless I see that x is equal to 4, this is not going to help me very much. And I've got a base of 3 that the calculator does not handle well, at least traditionally has not handled well. Okay. Now, there is a way that I could do this on the calculator. If I go to math, this is a new thing in the calculator not too long ago. I go to math and cursor down this list and find option A, which is log base. When I press enter, the calculator will let me work with log base 3 of 81, and I get 4. So x equals 4. Whoops. So that's an option. X equals 4 that way. Okay. Let me fix my page here. What I prefer to do is start with 81 equals 3 to the x, or 3 to the x equals 81, either way. In fact, I'm going to write it that way. 3 to the x equals 81. What I'm going to choose to do is, because my calculator works best with base 10, I'm going to just take the log of both sides. Then, remember that rule I said was important, that exponent can come down out in front, so this becomes x log 3 equals the log of 81. So now to solve this for x, I'm simply going to divide both sides by the log of 3. Log 3 divided by log 3 will be 1, and so x will equal the log of 81 divided by the log of 3. And I can try going to log 81 divided by the log of 3. And again, I'll get 4. So I've got either option. I'm going to recommend either this method here or this method here with the calculator. Quite honestly, I've been doing this longer than the calculator has been doing the log base. And I've gotten in the habit and the pattern of just looking at this way. And I've also practiced that I don't need to do these algebraic steps. I can just see that if I've got a to the x equals b, the x will be the log of b divided by the log of a. And I just don't need to write the work out. Of course, up here, there's not much work to write out either, but there are more keystrokes in your calculator. So quite honestly, it's a matter of preference. Okay, so number 7, either, new way, calculator log base, I could say log base 4 of 256 equals 2 minus 3x equals my exponent. So what if it's not just an x? Okay, then I can go to my calculator, math, go down to option A, log base 4 of 256 is 4 again, so 4 is 2 minus 3x. I'm going to subtract 2 from both sides and divide both sides by the negative 3. So x would be negative 2/3. So there's an option. The option that I would use would tell me, like I said before, this exponent here, so that exponent 2 minus 3x will equal the log of 256 divided by the log of 4. So 2 minus 3x will equal the log of 256 divided by the log of 4, which again is 4. And then I have the same algebraic steps. Subtract 2 from both sides, divide both sides by the negative 3. So either method of solution, quite honestly, I'm perfectly okay with. A couple more practice problems, and if you want to pause and try number 8, try number 9 on your own, and then restart the video, that would be fine. So for number 8, forgive me, I'm going to use my method that if I've got a to the x equals b, and I'll do this again, if I take the log of both sides, move the x down front, so x log a equals the log of b, divide both sides by the log of a, so that those will divide out to 1. So x is the log of b divided by the log of a. What's b? B is the constant, a is the base. So if I learn that pattern, I here just start with x equals the log of 100 divided by the log of 5. The log of 100 divided by the log of 5. Notice I'm closing the parentheses. And so x will equal 2.86. Okay. I'm going to go to 2 decimal places. So number 9, x will equal the log of 35 divided by the log of 7. So that will be the log of 35 divided by the log of 7. So x equals 1.83. Again, I'm going to go 2 decimal places. Okay. Just, to say it again, if you would prefer to say that log base 7 of 35 equals x, math, option A, log base 7 of 35, and notice you get the exact same value. Okay, so let's get number 10. Notice that number 10 is a little bit different because we have this 2 here. We don't just have a to the x equals b. So the first thing I'm going to do is divide both sides by the 2. 1.065 to the x equals 100 divided by 2, which is 50. So this brings it back to the form. So x is equal to the log of 50 divided by the log of 1.065. And I'm going to take that to my calculator. Log of 50, whoops, log of 50, not 20, 50 divided by the log of 1.065. So x is equal to 62.12. Okay. Now number 11, it's a little bit more difficult, right? 65 times 1.117 of the x equals 175. Same thing, the first thing I'm going to do is divide both sides by the 65. So 1.117 to the x is equal to 175 over 65. I don't feel like doing that division. Over here on the left, number 10, I did do 100 divided by 2 and get 50, and then found the log of 50. Over here, I don't feel like going to my calculator, doing the division, writing it down, re-entering it, and I don't need to. X will equal the log of the 175 over 65 divided by the log of 1.117. See, the reason I like this method better is it just, to me, is more comfortable. I don't need to do as much simplification. So now simply the log of 175 over 65 divided by the log of 1.117. X would be 8.95. Okay. So number 12, the only thing I've got different now in number 12 and 13, these are the last two we're going to look at today, but my exponent, I made a slight change. Instead of just an exponent of x or an exponent of t, I've got 2t and 3t plus 1. So same thing, divide both sides by the 500 first. So 500 divided by 500 is 1, so I've got 1.1 to the 2t, and 1,000 divided by 500 is 2. I'm only doing that division not because it's necessary, but because it's easy. So now 2t will equal the log of 2 divided by the log of 1.1. So now when I go to my calculator, I've got the log of 2 divided by the log of 1.1. Now that's not t, that's 2t. Is equal to the 7.27254, so on. To solve for t, I need to also divide this by 2. So t is 3.64. Okay. One last time. I'm going to start in number 13 by dividing both sides by the 725. 725 divided by 725 divides out to 1. So I'm left with 1.04 to the 3t plus 1. And that's equal to 15,000. Oh no, I got big numbers. It doesn't matter. 15,000 divided by 725. So my exponent, 3t plus 1, is equal to the log of 15,000 over 725 divided by the log of the 1.04. Notice it's the same pattern. Again, I go to my calculator, the log of 15,000 divided by the log of 1.04. Enter. So that's not t, that's 3t plus 1 equals 5.94479. So I'm going to subtract 1. That now is 3t. To solve for t, I'm going to need to divide that by 3. 1.65. Okay, so there's a quick look at logarithms. It's not a complete exploration of logarithms, but it is logarithms to the extent that we will need them for the remainder of this course.